Hi, my name is Dave Barker-Plummer with the OpenProof project CSLI at Stanford University. And this is another video demonstrating the properties of the Openbox application. In a previous video, we discussed how we could use the Openbox application to process specifications of representation systems described as XML files and generate Java code from them to implement that representation. The particular kind of representations for which we can do this are called single feature indicator systems. And single feature indicator systems consist of a set of roles, each of which has one and exactly one value from a set of values. In this video, we're going to demonstrate some more examples of single feature indicator systems and the way they're represented inside the Openbox. Again, throughout this demonstration, when I launch the Openbox application, the components directory will contain the proof bundle implementation of a particular kind of proof representation, fish style proofs, so that the system will start up with a notion of proof already inside it. We're going to start by looking at a representation that we call a work schedule. And there's something new about this kind of single feature indicator system, and that is that although the single feature indicator system consists of a set of roles just as before, these roles have some structure. In fact, our roles are going to be composed by taking the product of two smaller sets. So our representation is going to represent particular working schedules of a set of people and a set of days. So there are 5 people at Sushi, Dave, Emma, John, and Mike. And there are 5 days, Monday, Tuesday, Wednesday, Thursday, Friday. Our roles in this representation system are going to be the product of these sets. So there will be roles for whether Atsushi is working on Monday, whether Dave is working on Wednesday, John on Tuesday, and so on. As I just alluded to, the value set is very similar to the kind of value set that we've looked at before. This just has 2 values. Either a person is working on a day or is not working on that day. So that describes the feature, and the new part of the single feature indicator system here is that the roles themselves have some structure. As before, we're going to customize the realization. There's no real reason to do this apart from to demonstrate another property, another feature that the Openbox has. By using the string label role display widget, that's the one that we used for the early traffic lights, which have the names of the properties. If you use the string label role display with no customization, what you see is the name of the value displayed as the value. And what I'm doing here is saying that when the value is working, I'm going to just use this string instead as the value, and when I'm not working, I'm going to use this string instead. And this is just a fancy representation for a check mark and an X, respectively. So now, I can launch the Openbox application. Notice that the proof environment, the proof representation is already here. And I can drop my work schedule representation on the Openbox to create a new representation. Now when I start the Openbox, I can create a new diagram. And here's my work schedule diagram. The important thing to notice about this is that the Openbox has generated a display of this representation that is 2-dimensional. So the example that we had before was a traffic light. It had 3 roles and they were displayed as a 1-dimensional table. It's a single column of 3 roles. The Openbox has noticed that these roles are composed as a product and uses a 2-dimensional table to do the representation. So for example, this cell here represents the fact that Atsushi is not working on Monday. Can't possibly be right. Atsushi is a very, very diligent worker, so he works every day. Dave, on the other hand, takes a lot of vacation time, and so on. So this is a way of representing. Again, there's nothing different here about the single feature indicator system logic. So suppose in our original thing we had the property that Dave is not working on Monday. Suppose we infer, in fact, that Dave is working on Monday from some other source, then again these 2 representations close because they disagree on the value of Dave working on Monday. And of course, if I don't disagree, then this is an invalid step. So here, the thing to notice is that the fact that we have a product of roles, a product of role sets to create our actual set of roles, enables us to infer that we need to display this as a table of, a two-dimensional table of values rather than a one-dimensional table of values. Okay, so we just saw an example in which the roles in a representation can have structure, and when we pair roles together, we end up with a particular kind of table. In this demonstration, I'm going to demonstrate new features of the value set rather than of the role set. In this particular representation, which we're going to use to represent train timetables, we have again a product role set, and in this case the roles are formed by taking the product of station names, San Jose, Mountain View, Palo Alto, San Francisco, and SFO, and particular trains, train number 1, train number 2, train number 3, and train number 4. So again, the roles will be something like San Jose train 2, and the value is going to be the time at which train 2 arrives at the San Jose station. Now, there are lots of possible values that the times can take. So rather than enumerate them, we're just going to specify the values that are available to us in this representation by saying, well, look, they're strings. And the default value is going to be 00:00, that's midnight. I'm also demonstrating in this demonstration a new kind of part of the realization. We're not going to change the way the roles are realized. The roles are going to be displayed as role string, just as they were before, or role and value, just as they are in the plain traffic light. One of the problems, though, is now we have large numbers of values. Rather than using an editor that just advances the value when we click on the value display, what we're going to do now is we're going to construct what we call a click editor listener, which brings up an editor enabling us to enter the new value. And this editor is going to have a validator associated with it that only validates strings that meet this regular expression, and that this regular expression is designed to accept only legal times between 00:00 and 23:59. So when I launch the Openbox, again, just as before, the proof environment is available to us, and I can take my train typable representation, drop it onto the Openbox, restart the Openbox, and create a new train timetable representation. And here, San Jose train 1, these are the default values. Now when I click on the value, like I said, a little window comes up that enables me to edit values. If I enter a string, that's not going to be acceptable, but if I enter a valid time, for example 10:02, then San Jose train 1 gets to have the value 10:02. Maybe it takes 15 minutes to get there, so it's 10:17. And so I can bring up this editing that enables, the point of this is that I can construct a train timetable, but more importantly, that I can use arbitrary values that are strings, or indeed arbitrary values that are restricted to be valid according to one of these validators in my representation of, in this case, train timetables.